Practice set 3.4. 1. In a circle with center O, length of chord AB is equal to the radius of the circle. Find measure of each of the following. 1. Angle AOB. 2. Angle ACB. 3. Arc AB. And 4. Arc ACB. Solution. Observe the given figure. What type of angle is angle AOB? Correct. The vertex O of angle AOB is the center of the circle. Therefore, it is a central angle. We have to find its measure. Consider triangle AOB. In this triangle, segment OA is congruent to segment OB, since they are the radii of the same circle. It is given that the length of chord AB is equal to the radius of the circle. Therefore, chord AB is congruent to segment OA is congruent to segment OB. Therefore, triangle AOB is an equilateral triangle. Therefore, each of its angle measures 60 degree. Therefore, angle AOB is equal to 60 degree. 2. Next, we have to find measure of angle ACB. The vertex C of angle ACB lies on the circle. Arc AB subtends angle ACB at point C on the circle. We have studied the theorem. The measure of an angle subtended by an arc at a point on the circle is half of the measure of the angle subtended by the arc at the center. Now apply this theorem and find out the measure of angle ACB. In the figure, arc AB subtends angle AOB at the center and angle ACB at a point on the circle. Therefore, angle ACB is equal to half angle AOB, which is equal to 1/2 into 60 degree, that is equal to 30 degree. Therefore, angle ACB is equal to 30 degree. 3. Find the measure of arc AB. The central angle corresponding to arc AB is angle AOB. Therefore, by definition of measure of arc AB is equal to measure of angle AOB. Therefore, measure of arc AB is equal to 60 degree. 4. In this sub-question, we have to find the measure of arc ACB. Here, in the circle with center O, arc ACB is the major arc corresponding to minor arc AB. Therefore, measure of major arc ACB is equal to 360 degree minus measure of corresponding minor arc AB. Therefore, measure of arc ACB is equal to 360 degree minus measure of arc AB. That is equal to 360 degree minus 60 degree, which is equal to 300 degree. Answer. 1. Angle AOB is equal to 60 degree. 2. Angle ACB is equal to 30 degree. 3. Measure of arc AB is equal to 60 degree. 4. Measure of arc ACB is equal to 300 degree. Two. In the figure, quadrilateral PQRS is cyclic. Side PQ is congruent to side RQ. Angle PSR is equal to 110 degree. Find 1. Measure of angle PQR. 2. Measure of arc PQR. 3. Measure of arc QR. And 4. Measure of angle PRQ. Solution. It is given that quadrilateral PQRS is a cyclic quadrilateral. Therefore, its opposite angles are supplementary. Therefore, angle PSR plus angle PQR is equal to 180 degree. The measure of angle PSR is given to be 110 degree. Therefore, 110 degree plus angle PQR is equal to 180 degree. Therefore, angle PQR is equal to 180 degree minus 110 degree, that is equal to 70 degree. Therefore, measure of angle PQR is equal to 70 degree. Let this be statement 1. 2. Arc PQR is intercepted by inscribed angle PSR. By inscribed angle theorem, measure of angle PSR is equal to half measure of arc PQR. Therefore, 110 degree is equal to half the measure of arc PQR. Therefore, measure of arc PQR is equal to 110 degree into 2, that is equal to 220 degree. Therefore, measure of arc PQR is equal to 220 degree. Let this be statement 2. 3. Now let's find the measure of arc QR. It is given that chord PQ is congruent to chord RQ. the arcs corresponding to congruent chords are congruent. Therefore, arc PQ is congruent to arc RQ. Let measure of arc PQ equal to measure of arc RQ be equal to x. Then, by arc addition property, measure of arc PQ plus measure of arc RQ is equal to measure of arc PQR. From statement 2, therefore, x plus x is equal to 220 degree. Therefore, 2x is equal to 220 degree, and therefore x is equal to 220 degree upon 2, which is equal to 110 degree. Therefore, measure of arc PQ is equal to measure of arc QR is equal to 110 degree. Therefore, measure of arc QR is equal to 110 degree. 4. To find the measure of angle PRQ, we can use inscribed angle theorem. Angle PRQ intercepts the arc PQ. Therefore, measure of angle PRQ is half the measure of the intercepted arc, that is arc PQ. Therefore, angle PRQ is equal to 1 upon 2 into measure of arc PQ, which is equal to 1 upon 2 into 110 degree, since we know from statement 3 that measure of arc PQ is equal to 110 degree. So this is equal to 55 degree. Therefore, measure of angle PRQ is equal to 55 degree. Hence the answer: 1. Measure of angle PQR is equal to 70 degree. 2. Measure of arc PQR is equal to 220 degree. 3. Measure of arc QR is equal to 110 degree. 4. Measure of angle PRQ is equal to 55 degree. 3. Quadrilateral MRPN is cyclic. Angle R is equal to 5x minus 13 degree, and angle N is equal to 4x plus 4 degree. Find measures of angle R and angle N. Solution: quadrilateral MRPN is a cyclic quadrilateral. Therefore, its opposite angles are supplementary. That is, angle M plus angle P is equal to 180 degree, and angle R plus angle N is equal to 180 degree. Angle R is given to be 5x minus 13 degree, and angle N is given to be 4x plus 4 degree. Therefore, angle R plus angle N is equal to 5x minus 13 degree plus 4x plus 4 degree. Therefore, 5x minus 13 degree plus 4x plus 4 degree is equal to 180 degree. Therefore, 9x minus 9 degree is equal to 180 degree, which means 9x is equal to 180 plus 9, that is equal to 189 degree. Therefore, x is equal to 21 degree. Now, angle R is equal to 5x minus 13, so that is equal to 5 into 21 minus 13, which is equal to 105 minus 13, that is equal to 92 degree. And angle N is equal to 4x plus 4 degree, so that is equal to 4 into 21 plus 4, which is equal to 84 plus 4, that is equal to 88 degree. Therefore, angle R is equal to 92 degree, and angle N is equal to 88 degree. Four. In the figure, segment RS is the diameter of the circle with center O. Point T lies in the exterior of the circle. Prove that angle RTS is an acute angle. Here's the proof. Draw segment RT. Let it intersect the circle at point P. Join PS. Angle RPS is the angle subtended by diameter RS at point P on the circle. Therefore, angle RPS is equal to 90 degree, since angle subtended by the diameter is a right angle. Therefore, segment SP is perpendicular to segment RT. Therefore, angle SPT is equal to 90 degree. Therefore, triangle SPT is a right angle triangle. Now, in triangle SPT, angle SPT plus angle PTS plus angle TSP is equal to 180 degree, since the sum of the measures of all the angles of a triangle is 180 degree. Therefore, 90 degree plus angle PTS plus angle TSP is equal to 180 degree. Therefore, angle PTS plus angle TSP is equal to 90 degree. Therefore, angle PTS is less than 90 degree. That is, angle RTS is less than 90 degree, since point P lies between points R and T. Therefore, by definition of acute angle, angle RTS is an acute angle. 5. Prove that any rectangle is a cyclic quadrilateral. Let us draw a rectangle and name it as ABCD. So, given that quadrilateral ABCD is a rectangle. The proof. In rectangle ABCD, angle A is equal to angle B is equal to angle C is equal to angle D is equal to 90 degree, since each angle of a rectangle is a right angle. Therefore, angle A plus angle C is equal to 90 degree plus 90 degree, that is equal to 180 degree. And angle B plus angle D is equal to 90 degree plus 90 degree, that is equal to 180 degree. That is to say, the opposite angles of rectangle ABCD are supplementary. Therefore, by converse of theorem of cyclic quadrilateral, rectangle ABCD is a cyclic quadrilateral. Six. In the figure, altitudes YZ and XT of triangle WXY intersect at point P. Prove that 1. Quadrilateral WZPT is cyclic. 2. Points X, Z, T, Y are concyclic. The proof. It is given that YZ and XT are the altitudes of triangle WXY. That is, YZ is perpendicular to XW and XT is perpendicular to WY. Therefore, angle YZW is equal to 90 degree and angle XTW is equal to 90 degree. That is, angle PZW is equal to 90 degree and angle PTW is equal to 90 degree, since YPZ and XPT. Therefore, angle PZW plus angle PTW is equal to 90 degree plus 90 degree, that is equal to 180 degree. But these are the opposite angles of quadrilateral WZPT. Therefore, by converse of cyclic quadrilateral theorem, quadrilateral WZPT is a cyclic quadrilateral. Now let us prove the second part, that is, points X, Z, T, Y are concyclic. Given that angle XZY is equal to angle XTY is equal to 90 degree. Therefore, points X, Y on line XY subtend equal angles at two distinct points Z and T that lie on the same side of line XY. If 2 points on a given line subtend equal angles at two distinct points on the same side of that line, then the 4 points are concyclic. Therefore, points X, Z, T, Y are concyclic points. Seven. In the figure shown here, measure of arc NS is equal to 125 degree. Measure of arc EF is equal to 37 degree. Find the measure of angle NMS. Here's the solution. Angle NMS has its vertex M in the exterior of the circle and intercepts two arcs, arc NS and arc EF. Measure of angle NMS is equal to half measure of arc NS minus measure of arc EF. So that is equal to 1/2 into 125 degree minus 37 degree, which is equal to 1/2 into 88 degree, that is equal to 44 degree. Therefore, angle NMS is equal to 44 degree. Eight. In the figure, chords AC and DE intersect at B. If angle ABE is equal to 108 degree, measure of arc AE is equal to 95 degree, then find the measure of arc DC. Here's the solution. Chords AC and DE intersect at point B in the interior of the circle. Angle ABE intercepts arc AE and its opposite angle, that is angle DBC, intercepts arc DC. Angle ABE is equal to half measure of arc AE plus measure of arc DC. Therefore, 108 degree is equal to 1/2 into 95 degree plus measure of arc DC. Therefore, 108 degree into 2 is equal to 95 degree plus measure of arc DC. Therefore, 216 degree is equal to 95 degree plus measure of arc DC. Therefore, measure of arc DC is equal to 216 degree minus 95 degree, that is equal to 121 degree. Therefore, measure of arc DC is equal to 121 degree.